Alright, this is going to be a short unit on geometric sequences, and before we can really go any further, we need to know what is a geometric sequence. For these first few problems, we have to decide, are they arithmetic or geometric or neither? So we have these sequences. If it's going to be arithmetic, we're looking for something to be either added or subtracted over and over again to get from one term to the next. If it's going to be geometric, we're looking for there to be a multiplier, something that you could multiply by to get you from one term to the next. So if it was going to be arithmetic, if you subtracted, if you did 24 minus 6, all right, you see that's going to be 18. If this is arithmetic, then we should get the same thing when we look at the next two terms. So if I do 96 minus 24, well, that's 72. So this was increased by 18, but then between 24 and 96, that increased by 72. So if this were arithmetic, those would have been the same. So it's not arithmetic. Now let's decide if it's geometric. The way you check to see if it's geometric is you take each term and you divide by the previous term. If it's geometric, you should get the same thing over and over again. So for example, if I do 24 divided by 6, all right, obviously that's going to give me 4. Now, if I do 96 divided by 24, does that give me the same thing? Alright, so that is also 4. And let's check the last one. If I do 384 divided by 96, and that gives me 4 as well. So this is what it looks like when you have a geometric sequence. Alright, so that one was definitely geometric. Alright, look at number 2. Alright, from 1 to 3, that's an increase of positive 2. From 3 to 7, that's an increase of 4. So it's definitely not arithmetic. We can rule that out. Is it geometric? Well, again, to check, we test each term divided by the previous term. So 3 divided by 1, obviously that's 3. But then if I do 7 over 3, that's 7 over 3. That doesn't reduce. But it's definitely not 3. So that means it's not geometric either. So this one is neither. Okay, now let's look at the last one. From 4 to 13, all right, that's an increase of 9. From 13 to 22, that's an increase of 9. From 22 to 31, that is also an increase of 9. It's going up by 9 each time, which makes this one arithmetic. Okay, so if there's a constant difference where you're adding or subtracting each time, that is arithmetic. If there's this common ratio where if you divide each term, you get the same value, that's geometric. So it's the geometric kind that we're going to focus on today. Okay, for problem number 1, this number 4 is called the common ratio, and we use R to represent that. Alright, we call it the common ratio because if we take each term and divide by the previous term, that's how we get it. But when you look at the sequence, to get from one term to the next term, you would actually multiply by this common ratio. So if I did 6 times 4, I get 24. 24 times 4, I get the 96, and so on. Okay, so looking at number 4, if I just want to find the common ratio, I can just pick any term and divide by the previous term. So I can do 40 divided by 5, so the common ratio is 8. Okay, this is a little bit more awkward, but with a little help from the TI-30XS Multiview, this will not be a problem either. Because we can just take any term, like 1/8, and divide by the previous term. In this case, -1/4. Okay, now you can do this in the calculator if you need to. All right, this would be 1/8. Okay, and then divided by 1/4. Let's make that -1/4. Okay, and that turns out to be -1/2. So that's the common ratio, is -1/2. In the past, you guys have learned something called keep, change, flip, maybe, is something that you've heard. When you divide one fraction by another fraction, you can think of it as keeping the first fraction, changing from division to multiplication, and then doing the reciprocal of the second fraction. So this would be -4/1. So keep, change, flip, if you were trying to do this by hand. So that would be -4/8, which of course is where we get the -1/2 from. Either way, that's the common ratio. Okay, look at number 6. Do you remember back when we would find equations of lines? And the model that we would use was y = mx plus b. And so m would be the slope and b would be the y-intercept. So we got it into our heads that if we needed the equation for a line, all we needed were these two things. We needed the m and we needed the b. So if we had those, so say if the slope turned out to be 1/2, that would go here. Let's say the y-intercept was 3, that would go here, and boom, we'd have an equation. All right, but all we needed were two things. We needed the slope and the y-intercept. We could write the equation. There's a similar model, all right, because that was for linear when we had straight lines. Now, geometric sequences are really exponential equations, and they will have exponential models. All right, so here's the model for a geometric sequence. All right, AN represents the nth term of the sequence, first of all. In other words, looking at other sequences that we've had, if I have a sequence like this that goes 6, 24, 96, 384, the first term would be called A1. The second term would be called A2, and so on. This 96 is A3, 384 is A4. So putting A and then a number, that A, that represents that particular term in the sequence. So if I just say AN, obviously that's a variable, meaning the nth term, whatever n is. That, if I say if n is 7, then AN is the 7th term. If n is 20, then AN is the 20th term. It's a variable. Okay, you can think of AN as basically a y value. Because if I made a table of values, you know how we normally put x and y like this, and x might be like 1, 2, 3, and then so that would be the input, and then you have the output values, whatever you get. But in the context of a sequence, the x values are just tell you which term you're talking about: first term, second term, third term, and then the y values are the sequence itself. So if the input is 1, then the output is 6. So the y values are like the 6, the 24, the 96, and so on. But instead of using x and y when we're talking about a sequence, we talk about n and then an. Okay, so when you look at this equation, this an is just like the y value, okay, and this n is just like the x value. All right, now, just like when we did linear equations and there were two things that we needed to write the equation, slope and y-intercept, when we do a geometric sequence, there are two things that we need. Now, based on what I just explained to you, what does A1 represent? All right, if you were paying attention, you probably said A1 represents the first term in the sequence. In this case, it would be 6. Okay, so that's one of the two things I need to write the equation of a geometric sequence. I need the first term. Now, R, we also talked about a moment ago. R was the common ratio. The common ratio. Okay, and that was that ratio you got by taking each term and dividing by the previous term. It's the multiplier. So those are the two things we need. So basically you need to memorize this equation the same way you memorize y equals mx plus b. For this unit, you need to memorize that each term in a geometric sequence, the equation could be a1 times r to the n minus 1 power. And the two things we need are the first term and the common ratio. All right, so looking at number 6, we're given this sequence, and we're told write a rule for the nth term, then find a6. Okay, of course, a6 is going to be the 6th term. So first of all, is this arithmetic or geometric or what? Now you see that this goes up by 5, and then from 10 to 20 it goes up by 10, so it's not arithmetic. So hopefully it's geometric. If it's geometric, there should be a common ratio, this r value, which we would get by doing each term divided by the previous term. So 10 divided by 5, that's 2. 20 divided by 10, that's 2. 40 divided by 20, that's 2. All right, so each term divided by the previous term, that tells us that there's a common ratio of 2. Also, I mean, this one is simple enough that you can just look at it and see that here from 5 to 10, you multiply it by 2. 10 to 20, you multiply it by 2. 20 to 40, you multiply it by 2. So if you see this multiplier that's obvious to you, that multiplier is the common ratio. Okay, so that tells us that R is 2. Now, there are only two things that we needed. We needed the R and we needed A1. We just found the R value. Okay, that common ratio is 2, so we can put that in. We also need A1. How are we going to find that? Yeah, you're right, it's right there. A1 represents the first term of the sequence, and there it is, it's 5. Okay, that was easy. Alright, so that's it. That's how you can write the rule for this geometric sequence. Alright, each term should be 5 times 2 to the n minus 1 power. So if I want to use this to find the 6th term, let's do that. The directions say find the rule, which we did, but then we're supposed to find a6. Alright, so it goes like this. a6, you know, the 6th term, should equal, now we're just going to use the rule that we just created. So 5 times 2. Now these n's always match. You know, if we're talking about the 6th term, then that means n is 6. So we're talking about the 6 minus 1 power. Alright, in other words, this is 5 times 2 to the 5th power. Now I'm pretty sure the 2 to the 5th power is 32, but If you had any doubt, you could consult your calculator. So we're doing 5 times 2 to the 5th power. Okay, so that comes out to be 160. All right, so that's what A6 is. So the 6th term of the sequence should be 160. You know what? Let me show you one other thing. Go back to the calculator, and let's just type in the rule in the table, using the table function. Okay, so back in the calculator, let's just clear this out. Hit the table button on your TI-30. All right, let's get rid of that equation. Now, it doesn't say AN, but that's okay. We'll just recognize that the Y value is the AN. But let's type in the rest of the equation. So it was 5 times 2, and then it was to the n minus 1 power. Now, your calculator doesn't do n, so we'll just use x to the x minus 1 power. So if we do this, and let's go ahead and just start at 1, all right, because all of these always start at 1. Okay, so these y values should be the terms of the sequence. So I see I have 5, 10, 20, and if I look at my sequence, 5, 10, 20, 40. Okay, so if I scroll down, next one is 40. So you can see these y values are the sequence. And the x values tell you just which value you're looking at, first, second, third, fourth. So if I go to the 6th term, okay, this should be A6. And sure enough, it is 160. All right, so that's another way to look at it using your calculator. You really, it's like checking your answer. So it's almost impossible to get these wrong. All right, let's move on. All right, looking at number 7. Assuming for a moment that this is a geometric sequence, then there should be a common ratio. And I should be able to find that common ratio by taking each term and dividing by the previous term. So if this is geometric, then the common ratio is -5. Now let me just double check. And does 150, what do you get when you do 150 divided by -30? Well, that is also -5. Okay, so it's geometric and the common ratio is -5. We're supposed to write a rule and then find the 6th term. To write a rule, we just need two things. We need the common ratio and the first term, the R and the A1. Well, we just found the common ratio. It's -5, so that goes right there. All we need is the first term, but that's obvious because it is 6. So bam, we found the equation, there it is. Now all we need to do is find the 6th term. This time I'm going to go ahead and just go straight to the calculator. Shall I? No, I'll do it both ways. I'll do it both ways once again. So the 6th term, A6, should be, all right, and here's my rule, so it should be 6 times -5. Now this 6 has nothing to do with that 6, that's just a coincidence. But this always matches. So it's the 6th term, so that means n is 6, you know, the n, those match. 6 minus 1. So that means the 6th term should be 6 times -5 to the 5 power. So in the calculator, 6 times -5 to the 5th power, I should be looking at -18,750. So -18,750. Now let's check this using the table feature as well. Okay, so back to the table. Let's clear that out. We had 6 times -5 to the n minus 1 power. All right, so here we've typed in the equation. Let's start at 1. See what we've got. All right, the first three terms are 6, -30, 150. 6, negative 30, 150. So we have a match. Right away, we know we had the right answer. Okay, that's a way of checking your answer. Now let's look for that sixth term. So if we just scroll on down, we find that the sixth term is in fact negative 18,750. All right, I just wanted you to see both ways of solving the problem. All right, let's look at one more of these. All right, to find the rule, we need two things. We need the first term and we need the common ratio. Let's go ahead and find that common ratio, which should be, just pick any term, in this case a negative 5 over 3, I'm going to pick that term, and then divide by the previous term. So, we're just going to do divided by 5. So negative 5 over 3 divided by 5. Okay, so I could go negative 5 over 3 divided by 5. Yeah, that's right. And I get negative 1/3. By the way, I could have done it this way as well. I could have said negative 5 over 3, and I could have said just divided by 5, like that. Either way, I should get negative 1/3. All right, so fine. That means R is negative 1/3. That's the common ratio. Okay, so as far as writing this rule, I can just go ahead and put in negative 1/3. Of course, A1 is just the first term, so I can just erase this and put in 5. So this is the rule for the geometric sequence. All right, now this time I'm just going to go straight to the table feature. I'm going to skip the doing it by hand part, because I think you get it. So let's just put this in the use the table feature of the calculator. So what we have here is 5 times negative 1/3. All right, to the n minus 1 power. All right, I like to start off at 1 to check my answers. Okay, so my first three values should be 5, negative 5 over 3, and 5 over 9. 5, negative 5 over 3, and 5 over 9. So right there, I know I have the right equation. So now all I have to do is say what is the sixth term, A6. And of course, I can just scroll down. So there's my sixth term, and it is negative 5 over 243. So negative 5 over 243. Okay, that is how you find the rule for geometric sequence. If you're given the sequence itself, this is how you find the rule, and then you can find any other term that you want. All right, I'm just going to do these last two super easy examples, and then I'm going to cut this video, and the rest will be started in the next video. Now for number 9, I told you there are only two things we need in order to write the equation, write the rule. We need the first term and we need the common ratio. But in number 9 and 10, they give us both of those things just straight out. They give us the first term and the common ratio. So that is just a gift, and it's almost too easy. So they gave us the first term, A1 is 4, and they gave us that the common ratio is 3. All right, so there's the rule. So I guess all we really have to do is find A6, but we will just put that in our calculator, use the table function. So that's 4 times 3 to the n minus 1 power. Okay. And there, the sixth term is 972. Okay, and it's the same thing really for number 10. The rule should be the first term, which is 45, times the common ratio to the n minus 1 power. And again, to find the sixth term, we will just put this in the calculator. Okay, so it's 45 times 1/3. Wow, that is a fail. Okay, 1/3 to the n minus 1 power. All right, so I see the sixth term is 5/27. Okay, that was almost too easy. All right, look, I'm going to stop this video here. So what we learned today was how to write the rule for a geometric sequence. We learned that we need two things in order to write the rule. We need the first term and we need the common ratio. In all of these examples, well, I either just gave you the first term and the common ratio, or you were given the sequence itself. So now you know how to write the rule if you're given the sequence. In the next video, we're going to look at some problems where you're not given the sequence and you're not given the first term either. So we're going to find out how to write the rule for a geometric sequence if we're given any term and the common ratio. So I hope this has been helpful to you. If so, a like is always appreciated. A little thumbs up helps me out. And hopefully you'll stay tuned and go ahead and watch the next video that picks right up from here.